Good morning, class. We are going to discuss section 1.6, which is over midpoints and distance in the coordinate plane. So get your game faces on and let's go this morning. Again, you need to write down the title in your notes, section 1.6, midpoint and distance formulas. And you need to make a note of the number 5, just in case we answer it somewhere along the way. I might go ahead and read through the objectives. Looks like we're going to be applying the midpoint formula. We're going to be discussing distance formula, and also probably something you're all familiar with is the Pythagorean theorem. So we'll be using that also in today's lesson, so we'll be revisiting it. Couple of quick things that we need to understand is what a coordinate plane is. It was in the title, so therefore we must kind of know what it is. By the definition, a plane that is divided into 4 regions by a horizontal line, which is called the x-axis, and a vertical line, which is called the x or the y-axis. So if we're going to label these here, this one up and down would be the y-axis. This one right across your page is the x-axis. So it divides it into 4 regions, which we call quadrants. So this would be quadrant 1. This would be quadrant 2. This would be quadrant 3. And your final quadrant would be quadrant 4. So this point right here in the middle, we call that the origin. And then locations around the coordinate plane is marked by ordered pairs. In an ordered pair, your x value comes first, followed by your y value. So the first number tells you what you're going to move left or right. And your second number is going to tell you what you move up or down. So your x here and your y here. For instance, if we're going to graph -2, 3, well, here's your starting point, the origin. Well, the -2 is our x, so that tells us to go 2 to the left and then up 1, 2, 3. So here would be the point -2, 3. Remember that points are named with capital letters, so if that was a J in front of that ordered pair, then we'd put J right by the point, so it would be point J. Well, the first formula already is coming up. It says the midpoint of a line segment. The midpoint formula gives us the middle point of the line segment. And the formula, it basically tells us to take the averages of the x's, and that will be our x-coordinate, and then it tells us to take the averages of the y's, and that will be our y-coordinate. So right here, we have 2 points given to us, point A and point B. To figure out where the midpoint is of point A and B, or segment AB, then we apply the formula. I like to label everything first. So if this is my first point, I'm going to call it x1 and y1. If this is my second point, I'm going to call it x2 and y2. So my formula states, take my x1, which is 3, plus my x2, which is 5, and divide that by 2. That will give me the x-coordinate. For my y-coordinate, I locate my y sub 1, which is 1, and I add to it my y sub 2, which is 4, and I divide that by 2. So 8 would be 3 plus 5, so I'd have 8 divided by 2, which would be 4. And then 1 plus 4 would be 5 divided by 2, So I could leave it as 5/2, or 2.5 might make a little bit more sense for you. Okay. So the lesson should be up there. There's some hints if you need those, if you're working through the lesson on your own. Hopefully you're able to follow that. Alright, we're going to skip the problems on this right now because they'll be covered in your worksheet that you'll click on and do through the student portal. The next example here, we have an example using the midpoint of segment R. It says S is the midpoint of segment RT. R has the coordinates -6, 1, and S has the coordinates -1, 1. It wants us to find the coordinates of T. Okay. So I'm going to write the midpoint formula down here real quick. So we got the midpoint is equal to, well, we have our x1 plus our x2 divided by 2. And we've got our y1 plus y2 divided by 2. Now I'm going to focus just on the x coordinates formula real quick. So I know my midpoint of the x is equal to x1 plus x2 divided by 2. So let's see what we know. We know that S is the midpoint. So this would be my M sub x is what I've called it over here. So M sub x, that's my midpoint value, is -1. I'll plug that into the formula real quick. And now I know that my x sub 1 is R's x coordinate, which is -6. So I'm going to plug that in for my x sub 1. So I'll have -6 plus x sub 2 over 2. Well, to solve this, we can go ahead and set up a proportion by putting the -1 over 1. And now we just cross multiply. So I'll have 2 times -1, which is -2, equals -6 plus x sub 2. Well, to figure out what x sub 2 is, I need to take the -6 over to the other side. So I'm going to go ahead and add 6. And it looks like 4 is going to be my x sub 2. So we're trying to find the coordinates of T, which is the other endpoint of this segment. So therefore, x sub 2 is equal to 4, which means that T's x coordinate would be 4. I still got to find the y for my T. So I'm going to go ahead and erase all this work over here. And I'm going to put M sub y for a midpoint of my y's. The average of my y's is going to be y sub 1 plus y sub 2 over 2. Well, I know that the y's midpoint, what I'm calling M sub y, is going to be 1 now. So I'm going to fill in 1 for it. And I know that my y sub 1, or one of my coordinates, is given to me as -1. I'm going to add y sub 2 to it and divide it by 2. Well, from here it's exactly the same as what we just worked. I'm going to put this over 1. I'm going to cross multiply again. So I'm going to have 2 times 1, which is 2, is equal to -1 plus y sub 2. Well, if I add 1 to both sides, then now I can figure out what y sub 2 is going to be. So it looks like y sub 2 is going to be 3. So the other endpoint of my RT segment would be 4, 3. Another way that we could look at that, let me get this erased again for you. Again, if you need to pause and re-look at that, that's fine. Just rewind and look at what you need to. I'm going to go ahead and plot what I know up here. So I'm going to go ahead and start by plotting S at -1, 1. So I'm going to go over here, -1, and here's my midpoint. Now I'm going to go ahead and plot one of the endpoints that I know, which is R, at -6, 1, 2, 3, 4, 5, 6, and -1. So here's my R. Well, I know that this segment that I'm creating is going to start at R, go through S, and it's going to end up somewhere over here. So I know I'm looking for a point then that's going to be somewhere over here in quadrant 1 that's going to be called T. Another shortcut to this is if I count my rise over my run to S, if I do that same rise over my run, I'll end up at T. For example, I go up 2 to be even with S, and then I go over 2, 3, 4, 5 to get to S. So that means from my midpoint, I must go up 2 and over 5, 1, 2, 3, 4, 5, in order to get to T, and then I can just look to see what its coordinates would be. So 1, 2, 3, 4, up 1, 2, 3. So it looks like 4, 3 would be another way that I could get to T. So I'm going to pause the video. We're going to call that part 1 of 1/6.